So the walnut for the new PC case is carving away happily on the CNC. And whilst that's wearing away, I thought I'd share with you the control panel that I'm building into the case. This will sit on the top of the PC and let you see how the PC is feeling. Now, smart control panels are proliferating somewhat in custom PC builds these days, but they never seem to give you much control. So much of what affects a PC's performance includes things outside the case. Light levels, room temps, noise levels, dust levels, internet speeds, and more. I want to fix that and build a PC control panel that controls everything. Yes, Robot Downey Jr., that means you too. Today, I'll demo my new panel, show some of the logic I've built in, reveal 3 brilliant free bits of software that work together seamlessly to make this all happen, and I'll show off some of the cool ideas I've got that might get you inspired to do something similar. So what does smart control even mean? Well, it means switching to game mode doesn't just adjust the PC settings, but the whole room. It means it doesn't just know how the PC is performing, but every NAS, network connection and ping that affects it. It knows where you are and adjusts the whole room as you come and go. And it means the PC can not just adjust itself, but the entire house. So there's a lot more to this control panel than meets the eye. I have, of course, built this along my usual principles, so it's open source, modular, extensible. Let's get away from all these inhibiting applications used in these sorts of PC panels. Let's start by giving you a tour of the panel, because this is one of the ways the PC can alert you to its status. Right here on the top left, we've got a selection of temperature sensors. Not just your standard CPU and GPU temps, but also it senses the room temperature and the case air temperature too. So this means that my PC isn't just confined to the stats on the PC itself, it understands the environment that it's in. So sometimes your PC runs hot because it's rendering something tough, so turn the fans up. But sometimes it's running hot because it is hot, like in the summer. So with this setup, it can not only cool the PC, but cool the room. Now, down here, we have monitoring not just the PC, but all of my NAS drives. I depend on these just as much as my internal drives. So what's the point of having top-tier internals if your external storage or network speeds drag you down? In the top right, we keep an eye on internet speeds. Again, so many games and applications depend on this these days, so it's a direct factor that impacts my PC's performance. At the bottom right, it's all about storage. Instant visual alerts if I'm running out of space. Across the 4 NVMe drives and both NAS racks as well. So I can see at a glance all my storage states. In the centre, there's a brain that summarises up everything to clearly signal the overall health of my machine as a whole. When it turns red, something ain't right. Finally, there's a toggle switch at the bottom that lets me flip my whole room between gaming and work modes. And a couple of alert bars at the top to give me orders as required, like when I need to clean the dust filters. So this panel really is just the tip of the iceberg. This super smart control panel extends well beyond the touchscreen itself. Indeed, it contains an intelligent decision array that allows me to minimise interaction. It ingests over 3,000 data points every 5 seconds, which provides a baseline for its logic and allows it to extend far beyond the normal dumb panels. The first layer is the impulse layer. This is the simple layer, the stuff that PCs and control panels can generally do already. If the CPU temperature goes up, turn on the CPU fan. I don't add much to this layer, but I gather all the information in an InfluxDB database on my NAS so it can be made visible and tracked in incredible detail. If you want to see how your CPU temps fluctuate every 5 seconds over the last year, easy. Or how much hotter is your GPU overlaid with last year? Piece of cake. Layer 2 is the sentry layer. This is where I build combined logic, but the PC starts to show its sentience beyond the motherboard. For example, if the CPU temperature has risen and the room temperature is above a threshold, then turn on the room cooling. Layer 3 is the interpreter layer. This is where the PC really starts to think properly. By interacting with multiple devices and using advanced sensors, it can achieve much more intelligent experiences. For example, if no one is at the desk, then turn off the monitor and desk lights. If someone returns, turn them on. This uses a tiny mmWave sensor to act as a trigger, and these detect down to the breathing level, so you get none of those problems of old-fashioned motion sensors. Also, it preemptively controls things that affect the PC indirectly. For example, if the dust levels in the room rise above a threshold, it vacuums the room. Note that none of these involve human interaction. It's all seamless, automatic decision-making. Layer 4 is the alerter layer. This is where the PC starts to tell you what to do and really shows its sentience beyond the motherboard. So for example, if the CPU temperature has risen and the dust levels in the case are beyond a limit and airflow is below a certain level, then flag that the dust filters need cleaning. And it can tell you on the panel, on your phone, and even verbally. Yes, Aled can talk to me.
Of course I can talk, you simple human.
Well, of course, a superintelligence would have a Welsh accent. Layer 5 is the overseer layer. This is the final layer where the user wants to set predefined modes and tweak lots of settings inside and outside the PC. For example, setting to game mode will adjust the lighting, switch the sound to headphones, turn off periphery monitors, and ramp up the fan settings and more in just one click. Flicking back to work mode adjusts to daylight-based lighting setup, puts the PC into silent mode, and turns on ambient music to help with focus. So, that's the approach I've taken, minimizing user interaction wherever possible and just making things simple. Now, let's talk about assembly. Let me take you through the hardware and then 3 awesome bits of software that are free to make it all possible. The hardware is simply a touchscreen. There we go. You can just get these off Amazon, and I'll post a link down below in the description so that you can get one yourself if you like. I've set this up and you can power it with a tiny board like a Raspberry Pi, or just plug it into the GPU ports in the case and treat it as an extra monitor. There are pros and cons to both methods, and I'm still musing which way I'll take, but both work great. There's also a few extra sensors that I'm adding to give me even more data. Firstly, an air sensor to monitor everything in the room. Temperature, dust levels, light levels, and millions more. Secondly, an mmWave sensor. These are great because they detect sub-millimeter movements. So just breathing or your heart beating is enough to be detected. This means super precise presence detection that can really be used to detect where people are. Not just that, but it has zone detection. So I can tell it to turn the lights on if a person is in the room and turn them off when they leave. But then turn the monitors on when I'm in the seat and turn them off when I step away. This goes miles beyond the standard efficiency of PC sleep modes. Work out the maths yourself on, say, 15 minutes versus real-time presence detection, and how much electricity this will save you in each year. Both these sensors are from Apollo Automation, who I'll be reviewing in an upcoming video. If you're really impatient, then I'll attach a link in the description so you can grab one yourself. I've then 3D printed an insert to help frame it and integrate it nicely. And I did a little bit of cricketing with my trusty cricket to cut the copper vinyl and apply it to the panel to help it all link together with the final case. And that's it really for the hardware. Software. Now, as I've mentioned, there are 3 awesome bits of software that work together super powerfully to unlock all of this. The first, which will come as no surprise to anyone who knows me, is Home Assistant. So you can watch my other video to see more about Home Assistant, but it sits as the central control unit, gathering sensors from the PC and storing them and relaying commands to both the PC and devices from around the house. This is a great solution for this, as it means my smart control panel is not just limited to the 8 inches of the screen, but endless views on the PC and my phone for all the different use cases. This is great because things like dust levels in cases don't just happen over minutes and hours, but over months and years. So I can see the whole range of data in Home Assistant. Secondly, Hass Agent. This is a little gem of an application that is truly essential for any Home Assistant install. And shout out for Sam, who develops this and is always looking out for C# developers to help. So if you're a dab hand at that, then this is an amazing piece of software to support. I can barely do justice to it here, but it lets you gather sensor data from your PC, sends commands to trigger anything, and I mean literally anything. Open any web page, run an application, send the PC to sleep, switch off the monitors, use the PC as a media player for your music, announce things through the PC speakers using text-to-speech, pop-up alerts, for example, if someone comes to your front door when you're gaming. So I'm using this as the central interaction point of my control panel. It's gathering lots of data and sending it to Home Assistant, and Home Assistant can send it triggers, commands, and announcements to control the PC. WMI query and custom commands. Now, Hass Agent is powerful straight out the box, but there's a couple of commands that look innocuous enough, but truly explode the capability that you possess. Custom command, URL, key, and WMI query are huge. Think of what you can't do on your PC without a keyboard shortcut, an exe, a batch file, or a WMI query. The latter is a handy capability within Windows that lets you see everything about your OS, devices, user account, and system components with a simple SQL-like language. Not only does this allow a massive information from Windows itself, but any apps like Ada64, Libra Hardware Monitor, or the like appear with all their sensors available to pull into Home Assistant and onto my control panel. With these 3 apps, you can do just about anything you can dream up. Home Assistant already connects to everything in the house. So let's go through one example to show how this all hangs together. Okay, this is WMI Explorer. There's lots of different apps that essentially do the same thing, so do have a little Google. I've used another one that's slightly more tree-based in its layout, so you might find that one easier to use. I say this, but I've actually completely forgotten the name of it, so I'm sorry about that. But do let me know in the comments if you have any recommendations. You'll see I can just connect to my PC, then click on any of these namespaces. So let's pick Libra Hardware Monitor. Then click on Sensors. Then let's browse through, and you can see in the right-hand panel what these sensors are. Fans, CPU cores, and power. Let's use this one. Now just be careful about picking a persistent value for your query. So Instance ID will likely change each time you boot Windows, so something like this identifier looks much more constant. You'll see in the bottom left of the screen, it's actually writing example queries based on what you click. So this can give you a good starter if you're unfamiliar with SQL. So let's just copy that identifier and make a note of the SQL statement in the bottom left, and we'll paste those in later. Now let's jump into Has Agent. Click Sensors and add new sensor. Scroll down to WMI query and paste the SQL statement we need. This is a simple select statement, and the part you'll change is the identifier you want to grab. So let's paste what we copied earlier into this. You can also add scope, and I'm going to do this because it's a little bit more robust in case anything else is using the same identifier. Give it a name, store the sensor, and give it a quick test. Yep, that looks right. Store it, and bang, we're done. You've created a unique sensor that you can trigger to do loads of cool stuff. Now over to Home Assistant. If you look in your MQTT integration, that sensor is already available and automatically populated. So we really don't need to do anything, and it'll start populating the history for your charts. Let's jump to one of my sandbox dashboards. Add a new card. Let's make a sensor card. Grab the entity we just created. Give it a name, an icon. Set the units to watts, and we're done. Now let's create a simple command. So back to Has Agent, and let's create a command that will turn the monitors off. Under Command, click Add New, Monitor Sleep, Button, and we're done. This has now created a new button that's available in Home Assistant that will switch your monitor off. So let's just create a button to demonstrate. Just find the entity and it's all ready to go. This is great if I want to switch a monitor off from my phone if I forget late at night, which I always do. But you can also use it as part of an automation. This is how I'm using the mmWave sensors to switch my monitors off and on based on my presence. So as a silly example, using stuff we just made, we could say if the CPU load was above 75, then turn off the monitor and get Robot Downey Jr. to clean, which would be pretty random, but that's really how easy it is. I'm not trying to spoon feed you how to do each type of automation. It's more just to get your imagination whirring. So anything that your PC can detect can easily prompt you or another device to do something with just a few clicks. The question is more, what can you dream up? But one more thing. I will reiterate, I've never made a PC case before, so I'm very much just approaching this my own way. I'm sure I've missed things. So please do let me know if there's any other ideas that I could integrate. Likewise, I hope that there's a chance that coming at things with a fresh perspective can help innovate a little too. But I need your brains. As I said, there's over 3,000 sensors now at my fingertips. 100 devices across the house with thousands more that I can sense, trigger and monitor. So the possibilities are pretty endless. And these fingers are itching to make things. I'm always amazed at the creativity and imagination that people have. So please do let me know below what smart combinations of sensors, actions and automations I could create. The panel and the design can easily be changed, so I'd love to incorporate any great ideas. Catch you next time for the next case build video, where I'll have more sensors to test and wood to work. Hwyl fawr!